Next part of this chapter deals with mathematical proof, and this is where this chapter takes a definite turn for the more difficult. It's a part of the chapter I recommend you take very slowly and do every single question carefully, looking at the model solutions, making sure you fully understand it. Some of the proofs you're not going to know how to do unless you've seen a similar proof before, so it is one that rewards patience and practice. Okay, now with mathematical proof you need to be really clear when you're working because you effectively know the answer, so you need to make sure you show every single step of the working, and you need to make sure there's no gaps in your working, you've stated any assumptions that you're making, and you've covered all possible cases. Okay, so if you look at example 8, we need to prove that this equals this. Now you might notice that symbol isn't a straightforward 2 lines equal sign, it's got 3 lines. Now that symbol means identically equal to. So difference between equal to and identically equal to, for example, if you say 2x equals 8, well that's only true if x equals 4. Whereas if we said a plus b equals b plus a, well that's always true, it's always identical. So you'd use the 3 lines to show that it's always true. So in order to prove this though, it's quite a simple, straightforward proof because you know what to do. All we need to do is expand these brackets and show the expansion equals this. So firstly, multiply these two together. We get 3x squared. 3x squared, we've got 2x, take 15x, is minus 13x, minus 10. You can of course use a grid method or whatever method you prefer. Expanding these, I'm first going to multiply this by x, 3x cubed, 13x squared, minus 10x. Then I'm going to multiply all this by plus 7, so 21x squared. So it's going to be 91x minus 70. And then combining those, 3x cubed plus 8x squared minus 101x minus 70. And compare that to that. And then you can just put a hashtag to show that you've shown it's true, that this left hand side equals the right hand side as required. Example 9, if x minus p is a factor of x, prove f of p is 0, which is x with a factor theorem. Well, if x minus p is a factor of x, we can write f of x as x minus p times by another function involving x, so call it say g of x. F of p, where we swap the input value of x to p, is going to be equal to p take away p times g of p. Well, p take away p is obviously 0, and anything times by 0 is 0. Therefore, you've proven that if x minus p is a factor, f of p must be equal to 0. Example 10. We've got 3 coordinates, and they're the vertices. We need to prove that the vertices are a right angle triangle. Just do a quick sketch so you can see what's going on. 1, 1, 3, 3, 4, 2. So if we call that A, B, C, which I think it did in the question. Now, there are 2 ways of proving this. To prove it's a right angle triangle, we can look at the gradient to this line and the gradient to this line and prove that they're perpendicular by multiplying them together and the result being -1. Or you could work out the length of this line, length of this line, length of this line, and prove that Pythagoras' theorem holds. Either's absolutely fine. I think the gradient is a quicker method though. So if we look at the gradient of the line AB, we're going from 1 up to 3 up, so that's 2 up. From 1 across to 3 across is 2 across, so 2 over 2 up divided by across is 1. If we look at the gradient of BC, you can see we're going from 3 down to 2, which is 1 down, so that's -1 up effectively. And from 3 to 4 is 1 across, so -1 over 1 is -1. Then the gradient of line AB times the gradient of line BC is 1 times -1, which is -1. Therefore, AB is perp to BC, therefore and C is a right angle triangle. Okay, right. Example 11. It's meant to be a k, so we've got kx squared plus 3kx plus 2 is 0 has no real roots. Prove k is between 0 and 8/9 inclusive of the 0. Okay, our first clue how to do this is this statement has no real roots. You need to go back to that meaning b squared minus 4ac must be less than 0. So a is k, b is 3k, c is 2 because it's equal to 0. So we get, now be careful because lots of people here will put 3k squared. It's all of 3k squared, which is 9k squared minus 4k times 2 is less than 0. 9k squared minus 8k is less than 0. Don't divide by k or do something daft. What we need to do here is factorise out the k. Okay, and to solve a quadratic inequality, it's a good idea to draw the graph. So we're going to have critical points at 0 and 8/9. It's obviously happy because 9k squared. This is in terms of k now. And we're after where it's less than 0 below the horizontal axis, which is the k-axis. So it's when k is between 0 and 8/9. It's really careful here because if you don't look at this carefully, you think you're done. But look, it was including the 0. So you also need to test all cases. We need to test what happens when k equals 0. So when k equals 0, we're going to have 0x squared plus 0x plus 2 is 0. 2 cannot equal 0, therefore there's no solution. So there's no root there. So combining that with that gives us that k must be between 0 and 8/9 inclusive of the 0 as required. So how are we going down exercise 7D?